What's good, everyone? Welcome back to another video. Doing another LeetCode today. So this one is basically like a mirror from the previous one that I uploaded. So before it was like we faked a stack using queue. Now we fake a queue using stacks, right? And so once again, I'll be reading out the prompt, explain it a little bit, like the core idea. Write out the code, explain each line, and then finally end it with the time complexity and space complexity. Okay, so 232, implement queue using stacks. Implement a first in, first out FIFO queue using only 2 stacks. The implemented queue should support all the functions of a normal queue, so push, peek, pop, and empty. And then for the implementation, we have push element X to the back of the queue. We have pop, removes the front of the queue and returns it. And then peek, we just return whatever's at the front. Empty, just show if the queue is empty or not, true, false, yada yada. So it is just like the previous video. However, this time we are using 2 stacks to make a queue. So the core idea is we want a queue. So push, insert means we're going to insert whatever element at the back. Pop removes from the front. Peek, see the front, and we're only allowed to use 2 stacks. So, and the way we're going to be using it is I'm going to probably be making it called in stack and out stack. So in stack for incoming elements where we're going to push. And then out stack is for outgoing elements where we do pop and peek. Okay? So, well, how we're going to do it is when we call the push, we just push onto the in stack. And I'll write out the code too. So, and then when we need to pop or peek, if out stack is not empty, use its top since it's a stack, right? Whatever's at the top. And if it is empty, then move everything from in stack to out stack. Which means we're gonna pop from in stack, push to out stack. And then the oldest element is now on the top of the out stack, so this becomes the front of the queue, right? This way, when elements go in at the top of the in stack, and then when needed, we just flip the whole in stack into out stack, reversing the order. So that reversal basically makes it FIFO behavior. And if you couldn't understand what I said, I will write out the code and then show examples. Okay, so for here, let's just import Java, and we're gonna import stacks this time. Last time it was queue, but this time it's stack, and we don't need to import any like linked list this time or anything. So we're gonna private stack. We're gonna have it where it's integer. Now this is the one that I was talking about. We're gonna give the first one in stack. Let's have another private stack, integer, and this one will be out stack. So in stack for pushing new elements. And this one is for popping / peeking the front. Or technically, if you're looking at stack, it would be like on the top, you know, but we're trying to make this into a queue, so it would be in the front. Okay, so again, same thing. In stack will be the new stack, so like this, and then out stack will also be the same thing. So this. There we go. So what's sort of interesting is unlike the other one where we focused on mainly the push, this time what we're doing is we're gonna be focusing on the pop and the peek, because that's what matters for a question like this. So previous video, it was mainly like a lot of more stuff on the push, and like all you're doing is you're just returning the pop, peek, and empty, and that's it. But this time we're focusing on the pop and peek, where for push we just push it, you know. So for here it would just be like in stack dot push. You just push the element X to the back of the queue. Nothing else. And we'll come back to these two. And then for the empty is very simple as well. you just return instack dot is empty, and then but I also got to make sure outstack is also empty. There we go. So this basically returns whether the queue is empty or not. Now, something I do want to create is we're going to create this thing called shift stack, right? So I'm going to call it private shift stacks if needed. Now, the reason why I sort of want to create something like this is, and I'll comment it, is we're going to move elements from instack to outstack. And only do this if outstack is empty. Okay, so if outstack dot is empty, and then from here we're gonna do a while, and the reason for while is we're trying to sort of like try to pour everything from instack to outstack. So we're gonna do, so actually I'll comment it too. Pour everything from instack to outstack while instack is empty. Well, sorry, is not empty. Outstack dot push instack dot pop. So it's kind of like the previous question from my previous video, where it's like when we were doing the push, it like on the second step we're checking to see if like the first queue was empty or not, and that's why we had the while statement for that part too. Now this part will be needed for basically when you do the pop and peek, right? So, and I wrote it like this because, you know, there's two of them. So if I technically I don't need to, but then I'm going to have to rewrite the whole thing like on both pop and peek. So there's not really a need for me to do something like that. So I just wrote it down here. So we're going to call the shift stack if needed. And that's it. You just leave it there. And afterward, you will just want to do return stack dot pop. And then same with peek. So you call it shift stacks if needed. And then same thing, you just return outstack dot peek. And I believe that should be it. Okay. Yeah, that's basically it. So now here I'll just basically explain it. So from here to here, what we have is we just have two stacks. The in stack will be where, like, in stack is basically where all the new elements go here, right? Now out stack is what we're going to be using. We're going to basically use the out stack as like the front, quote unquote, the front of the queue. And initially they're both empty. Oh, excuse me. All right, push. Push is very simple. Queue push just means add to the back. So we simulate that by simply pushing onto instack, right? Now pop. So for pop, what we wanted to do is we want to remove the front of the queue first. So, but because of the structure, the front basically lives at the top of the out stack, right? So what we do is we have to call the function shift stacks if needed to make sure that out stack has the correct order. And then you do the outstack.pop, which removes and returns the top, which is the oldest pushed element. And then for peek is very similar to pop, but we don't need to remove any elements this time. And peek just returns the front value. Empty is very simple. The queue is empty only if both stacks are empty. But however, if there's anything like in either in stack or out stack, that means the queue has elements, so it cannot be empty. Now, with this part, clearly, this is sort of like where everything is gonna happen. Our main point is we only move elements when out stack is empty, right? So while in stack has elements, in stack.pop takes the top, which is the most recent, and then outstack.push pushes onto the top. So for example, let's say we call push 1, push 2, and push 3. So what happened here is, so that means right now in stack has 1, 2, and 3, right? And 3 is at the top because that was the last thing we pushed into it. So again, think of it as like a normal stack. So when we call 1, it's on the first, but when we call 3, which is the last one, it's stacked on the very top right now. So 3 should be on the top. And then out stack is empty. Let's say we call the first pop, right? We pop the first one. So right now, if we look at the shift stacks if needed, if out stack is empty, which it is, what we do is we're gonna shift. So while the in stack is not empty, which it isn't, we wanna do the out stack push and in stack pop, right? So we pop 3 from in stack and push it onto out stack. So it becomes like this. Oh, let me do this. So 3, 3. And then you do the same thing with you want to pop 2. So like that. And then finally, you want to do for the 1 and you're doing that because the while statement is like, the while is still true. Now it's no longer true because the in stack is now empty. So the while is no longer true. So now in stack is empty and out stack top is 1. See how like it shift? When we push it in, it was like 1, 2, 3. But now the out stack shows 3, 2, 1, where the 1 is basically on top of the stack now, or front of the line technically. And that's sort of how and then like because we asked for the pop, it's just gonna return 1, which is first in, first out. And then after that next pop, it was still, since like, because it's no longer the out stack, it no longer changes anything. Because like when we call pop a second time, do you need to shift? No, you don't need to, because the out stack is no longer empty. So when 1 is like, let's say when you pop the first time, 1 is gone. This time you want to check, do we even need to use the shift stack? No, we don't, because the out stack is no longer empty. So when that happens, when we pop again, it's just going to pop whatever's on 2, and it's going to pop the last one, which is 3. And that sort of shows like the order is 1, then 2, then 3, which is the first in, first out behavior. And I don't need to really explain for the peak, because the peak is the same thing, except all you're doing is you're not really popping anything. You're just checking whatever's at the front. So there's that. Now, let me just run it to make sure everything's fine. Like I don't have an error or anything. Okay, I do have an error. Where is it? Oh, all right, there we go. All right, looks good. Let's submit it. Perfect. Okay, good. Okay, now I'll just make a quick explain on the time and space complexity. Okay, so time complexity. Now, if you kind of look at it, what matters the most is the pop and peak, right? Previously, if we're doing the other questions, the previous questions, it was mostly everything else, like, was basically big O of 1. However, the push had a lot more, and like it was big O of n. Now we sort of like flip it, where the push is big O of 1 because it's super cheap, right? And then same thing with empty, you're just checking it and all that. However, for the peak and pop, it's sort of like the worst case scenario is big O of n. And this is basically like when we have to move everything from in stack to out stack. But most of the time, each element is moved at most once from in stack to out stack. So the average cost per operation is still big O of 1. But we like to think that we would always want to think about the worst case scenario. So we would sort of just basically look at it as big O of n. And then for space, again, space is also big O of n because we store every element in exactly one of the 2 stacks. So big O of n. So just like the previous one, stack using 2 queues, the push is very expensive, whereas this question where Q using 2 stacks, the pop and peek is more expensive. But in both space are both big O of n. Yeah, that's basically it. All right, thanks. Bye.